Welcome to Chemistry World. Most important questions: how will be there come? How will become from molecular orbital theory? Today, let me discuss how the question will be there and what type of things they will ask. How to solve that one in simple way, easy way, without any confusion. Let me see in simple steps. No need to go for complicated things. I'll explain in very simple manner how to identify the questions from MOT, molecular orbital theory. See, in examination, how we ask the question in MOT means which one has more bond order, which one has more bond length, which one has more bond energy, which is paramagnetic, which is diamagnetic, in which case bond order changes, in which case magnetic nature changes, in which case bond order increases, in which case bond order decreases. Like that the question will become. Directly we will give the examples, and in that examples we have to observe where the bond order is changing, where the bond length is changing, where the bond order is changing. We have to check. Before checking that one, first we should know some basic concepts of MOT. What is that basic concepts means? If bond order BO, I'm saying, if bond order is 3 for any molecule like N2, so generally the bond order 3 will be appear if total number of electrons are 14. If total number of electrons are 14, bond order will be 3. The 14 electrons may present in N2, may present in O2 2 plus, may present in C2 2 minus, may present in Cn minus, may present in NO plus. You can check here. 7 plus 7 here, 8 plus 8 minus 2 here, 6 plus 6 plus 2 here, 6 plus 7 plus 1 here, 7 plus 8 minus 1 here. You can write total electrons. Total number of electrons, if you are getting 14, that may be this one. Any one may be present. NO plus 14 electrons, En minus E2. In all this, like that you can check any one, etc. I'm writing. You can write anything. You can write anything. And CO also it is there. Another example, CO also is there. 6 plus 8, 14. Carbon monoxide, not cobalt. Carbon monoxide, capital C, capital O. In all these cases, 14 electrons are present. If 14 electrons are there, the bond order is 3. Bond order is 3. And magnetic nature that we discuss after writing the electronic configuration. Mostly in this case, the magnetic nature will be diamagnetic because no electron is unpaired in this case. In all these cases, electrons will be all electrons will be paramagnetic, that is paid electrons will be there, so diamagnetic. Why it is paramagnetic means the configuration of this one is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Up to this 8 electrons will be formed. After that pi 2px to pi 2py both have the same energy, so equal to, I am writing pi 2py2, so 8 plus 10 plus 12. After that sigma 2pz2 will be there. 2 2 2 2 2 2 2. In all cases 2 electrons are there, no unpaired electrons, that's why it is diamagnetic. Whatever the compound like this, N2, O2 plus, C2 minus. In all cases, whatever the ions I wrote here, that bond order is 3 and diamagnetic. This is the configuration. These are the electrons. If electrons are 15, if total electrons are 15, the bond order will be 2.5. You can calculate by using Nb minus Na by 2 formula. It will be get 2.5. If it is 2.5, the examples will be N2 minus, 1 electron extra, so I wrote minus here, and it may be O2 plus, 15 electrons here, 15 electrons here, then Cn2 minus, 15 electrons will be 6 plus 7, 6 plus 7, 13 plus 2, 15 will Cn2 minus, generally Cn2 minus will never exist, so no need to write. NO you can write, CO minus you can write, etc. You can take any examples. N2 minus, O2 plus, NO jar, CO minus, etc. All these cases. In this case, the configuration will be, and magnetic nature will be paramagnetic. Why we get paramagnetic means, I'll write the configuration. Here total electrons will be 15, means in this case molecular orbitals energy diagram little bit different. Up to 14 electrons molecular orbital energy diagram means first 2p, pi 2px, pi 2py, then pi 2pz will become later. Pi 2pz will become later. But in this case, the order will be like this: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then sigma 2pz will be there. Actually pi will be there up to 14 electrons. After 14 it will be sigma. After that pi 2px equal to pi 2py will be there, here 2, here 2. After that pi star 2px, one extra electron will become equal to pi star 2py 0, no electron, because 2, 4, 6, 8, 10, 12, 14, 15 finished. One unpaired electron in anti-bonding molecular orbital present in this case. So it is paramagnetic. Unpaired electron is present, paramagnetic. No unpaired electron, diamagnetic. Total electrons 14, 3. Total electrons 15, so 2.5. Like that you can write for 16 also. If it is 16, bond order is 2.0. It is also paramagnetic. The examples for this is N2 2 minus, O2, NO minus, CO2 minus, etc. you can write. In all the cases, bond order will be 2, and it is also paramagnetic. Why paramagnetic means extra electron will come here. Pi star 2p y1 will become pi star 2p x1 here is there na, like that pi star 2p. 2 unpaired electrons will be present in this case. So it is also paramagnetic. 15 paramagnetic, 16 paramagnetic, 14 is diamagnetic. And if total electrons are 17, bond order is 1.5, and it is also examples you can write anything: O2 minus, F2 plus, Ne2 2 plus, etc. you can write. Ne2 2 plus, etc. you can write. In this case it is also paramagnetic. It is also paramagnetic. Why means in last configuration pi star 2px2 equal to pi star 2py1 will become. In this case last configuration pi star 2px1 equal to pi star 2py1 will be there along with this. Here one unpaired electron is there, so it is paramagnetic. Bond order is 1.5 if total electrons are 17. If total electrons are 18, bond order will be 1.0. Example is O2 2 minus, F2 will become then Ne2 minus or 2 plus, no, here 17 na 20, Ne2 3 plus will become 17 electrons means, and F2O2 minus is there, F2 plus is there, right here. You can write O2 2 minus F2 plus, no 18 direct na, F2 Ne2 2 plus will be there. If 14 electrons are there, this one Ne2 2 plus 18 electrons. In this case, the last configuration is pi star 2px2, pi star 2py2 will be there, so it is diamagnetic. 18 electrons diamagnetic. Like that, you have to identify bond order, how the bond order will be there, how the magnetic nature is there, how it will be existed. So this is 18. 19 electrons, 20 electrons also you can calculate. For 19 electrons, bond order will be 0.5 and last configuration will be pi star 2px2 equal to pi star 2py2 and less than sigma star 2pz1 will be appear. Last configuration I am writing, last configuration. So in this case also one unpaired electron is there, so it is paramagnetic. Like that bond order electrons will be identified. Bond order. And if 20 electrons are there, you can take any example, just count the electrons in that. The bond order will be 0.0, no bonds between atoms. Best example is Ne2. Neon is noble gas, so it never forms any bonds between neon atoms because it is noble gas, no bonds. Ne2, and it is diamagnetic. Why it is diamagnetic means last configuration, if I write pi star 2px2 equal to pi star 2py2 less than sigma star, so it is sigma star 2p, sigma star 2pz2 we get. Sigma star 2pz2 we get. So here no unpaired electron, that's why diamagnetic. Like that, if electrons 14, 15, 16, 17, 18, 19, 20, magnetic nature configurations. Most of the students will be get confusion in this case with this configuration. If you see this one, if you understand this one, writing of bond order, bond length, bond energy, magnetic nature, number of electrons, unpaired electrons, total electrons, configuration, you can write easily. Just in case you have to be listen carefully and practice by taking any example. 14 electrons, how to write 15 electrons, and this is a shortcut of MOT. If you know this one, you can. In the same way, 13 electrons, 12 electrons, 11 electrons, 10 electrons, 9 electrons, 8 electrons also you can see. Let us see that one also. If you understood, please close this one, or else if you are not understanding, go to backward in this video and listen once again, you will understand. Still if you are not understanding, please say comment. I'll explain some more details with this, because more than this is not enough to understand the concept. If still not understanding, I'll explain in detail. Some more details I can explain. So ask me. If understood, no problem. More than enough this one. Still if you are not understanding, ask me. But how to write the molecular orbital diagrams for this is, I'll make one video. Please go through that video. You can see the diagrams, orbital diagrams. For competitive examination, you will not ask the orbital diagrams. You will ask this type of bond orders, configurations, examples, change of bond order. If the electrons are increased from 14 to 15, bond order will be decreased. magnetic nature will be changed. If it is changing from 15 to 16, bond order will be decreased. Magnetic nature will not be changed. If electrons are increased from 14 to 15, bond order will be decreased. Magnetic nature changed from diamagnetic to paramagnetic. If electrons are changing from 15 to 16, bond order decreases, magnetic nature do not change. Because here one unpaired electron for paramagnetic nature, here also two unpaired electrons for paramagnetic nature. Here it will be root 3 magnetic nature will become, in this case, root 2 into 2 plus 2, 4, 8, root 8 will become here. Means 2.83, like that magnetic nature will become. Here 1.73 will become. Magnetic nature changes when does not changes when electron changing from 15 to 16 electrons, total electrons. And if it is changing from 16 to 17, when the number of electrons are increased from 16 to 17, bond order changes from 2 to 1.5, decreases from 2 to 1.5. Magnetic nature do not changes, paramagnetic, paramagnetic. If it is changing from 17 to 18, bond order decreases from 1.5 to 1.0, and magnetic nature changes from paramagnetic to diamagnetic, and vice versa. If it is changing from 18 to 19, bond order decreases from 1.0 to 0.5. Magnetic nature also changes from diamagnetic to paramagnetic. If number of electrons changing from 19 to 20, bond order becomes 0, means 0.5 to 0 will be decreased, and paramagnetic nature convert into diamagnetic nature. Magnetic nature changes. So briefly once again I am saying, if it is 14 to 15, bond order decreases, magnetic nature changes. If 15 to 16, bond order decreases, magnetic nature do not changes, paramagnetic, paramagnetic. 16 to 17, bond order further decreases, magnetic nature do not changes, paramagnetic, paramagnetic. But magnetic nature changes. Here 2 unpaired electrons, root 8 will become, here 1 unpaired electron, root 3 will become, but paramagnetic, paramagnetic. If electrons, total electron changes from 17 to 18, once again bond order decreases from 1.5 to 1.0, and magnetic nature also changes from paramagnetic to diamagnetic. It is main concept. Most of the students will be lose the marks here without knowing this one. If you write the configuration just like this, I wrote only last configuration to identify the unpaired electrons. Based on that, I wrote magnetic nature and bond orders also there. Please see like that. And I will go for next. If electrons are decreased, here electrons are increased, 14, 15, 16, 17, 18, 19, 20. If the electrons are decreased, how it will be there? Let me see now. Now, once again, I'm going to that 14 electrons. Once again, I wrote. Remove that one. Okay, no issue. I'll write once again 14 electrons if it is there. What is the last configuration and all these things. Now, if total electrons are 14, bond order is 3.0, and configuration, last configuration only I am writing, that is after that pi 2px 2 equal to pi 2py2 will be there. So 8 plus 2, 10 plus 2. After that, sigma 2p Z2 will be there. This is last 3 orbitals configuration in a 14 electrons molecule or ion, or 14 neutral molecule, or positive ion or negative ion. What are that ions? Already I wrote in previous things. So 14 electrons it is there. And it is already told you that because 2 electrons are there, it is diamagnetic. Diamagnetic. So bond order is there. If total electrons are 13, the bond order will be 2.5. and the configuration becomes pi 2p x2 equal to pi 2p y2 less than sigma 2p z1 will be appear. 8 plus 5, 13. 8 means what? Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. 8 electrons. After that, this one. So here one unpaired electron is there. So it is paramagnetic. It is paramagnetic, that mu equal to root 3 will become. And if electrons are 12, you can take any molecule. 13 molecule example is N2 plus, C2 minus, NO 15, 2 plus, O2, not like that, NO is enough, N2 plus, like that. You can write any example. For 12 electrons, it will be C2, N2 2 plus, and you can write any examples like that. In this case, last configuration is pi 2px2 equal to pi 2py2. No electron, sigma 2pz, 12 electrons. Sigma 2pz is 0. Sigma 2pz is 0. So here all electrons are paired, so that's why it is diamagnetic. It is diamagnetic, and bond order in this case is 2.0. Bond order in this case is 2.0. If the electrons are 11, the configuration you can take any one. Pi 2px2 equal to pi 2py1. So then one unpaired electron is there, paramagnetic will be there, unpaired electron is there, and in this case bond order is 1.5 if electrons are 11, and if electrons are 10, bond order is our configuration is pi 2px1 equal to pi 2py1 will be there. So the bond order in this case is 1.0 bond order, and two unpaired electrons are there, so it is paramagnetic. It is paramagnetic, and that mu value in this case is root 8. In this case only one part, one unpaired electron is there, so root 3. Here mu equal to 0. Here root 3 will be there. If total electrons are 9, pi 2px1, pi 2py0 will be there. In this case bond order is 0.5, and one unpaired electron is there, so it is paramagnetic. It is paramagnetic. Mu equal to root 3 will be there. And if total electrons are 8, its configuration is pi 2px0 equal to pi 2py equal to 0. That is 8 electrons means sigma 1s2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2 will be there. So here also all are paired, that's why it is diamagnetic. Diamagnetic. Remember, if total electrons 14, bond order 3, diamagnetic. If electrons are changed from 14 to 13, bond order decreases to 2.5, diamagnetic becomes paramagnetic. So magnetic nature changes, bond order changes. If 13 to 12, bond order decreases from 2.5 to 2.0, and paramagnetic once again becomes diamagnetic. Here also magnetic nature changing, bond order changing. Magnetic nature changing, bond order changing. Here 12 to 11, if it is becomes, bond order changes from 2.2 to 2.0 to 1.5. Diamagnetic convert into paramagnetic. Magnetic nature changing, bond order changing. And if it is becoming 11 electrons to 10 electrons, bond order changes from 1.5 to 1.0, and paramagnetic nature changes to paramagnetic nature only. Means magnetic nature is not changing, but bond order is decreasing when electron changing from 11 to 10. When electron changing from 10 to 9, bond order changes from 1.0 to 0.5, decreases, and magnetic nature paramagnetic, paramagnetic. No change in magnetic nature. If it is changing from 9 to 8, paramagnetic nature converted into diamatic nature, bond order changing from 0.5 to 0.0, means bond order changing as well as magnetic nature is changing. Like that, you can identify magnetic nature, number of unpaired electrons, magnetic moment for 8 electrons, 9 electrons, 10 electrons, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Up to 20 you can see like this. And bond length, bond order, bond parameters I'll take in a next video. I hope you understood all these things. So very useful concepts. Most of the students will not understand these concepts. That's why they will lose the marks without their intention. So listen carefully this entire video, and before videos also, if it is possible, go through that one. You will get complete information. Still, if anybody has the doubts in this case, ask me in the comment. I'll explain once again to all these doubts what you have. Okay, thank you.